So here we've got problem number 10 on practice exercises 5. This is the question: what is the molar solubility in water of ionic compound silver chromate? And they give us the solubility product for it, and they give us 4 choices. This problem was a really tough one, and when it was given on an AP exam, the number of correct responses is only 25%, which is just random guessing. So let's see what this one's about. This one's worth a little bit of time. First of all, here's the question. Now we've got an ionic compound that is dissolving. This is silver chromate. It doesn't dissolve very well, but when it does so, it produces a small amount of silver ions and some of these chromates. It's a pretty experiment. Silver chromate's got this maroon color. Let me show you the reaction. Here it is. Here's a solution with some, could be potassium chromate or sodium chromate. Chromate ions produce this yellowish color. This is a pretty dilute solution of less than 1/10 molar. And they're going to drop in some clear silver nitrate. Nitrates are all soluble, so silver nitrate is going to be a clear liquid. And here we've got our soluble sodium chromate. So we're going to mix silver ions with chromate ions, and here's what you end up getting. Go, there it is. That's reacted to solution. And this solid stuff is the silver ions snapping together with the chromate, producing this very distinctive color. Now, what's involved in this? Well, KSP, this is an equilibrium reaction where we have very few silver ions and chromate ions. You know how to write an equilibrium expression, this KSP equation. The coefficients become superscripts. 2 comes here, the 1 becomes here. That's the nice thing about equilibrium expressions. Coefficients become exponents. We don't include the solid in it because solid concentrations don't change. If this had been an aqueous silver chromate, it would be down here at the bottom in a denominator, silver chromate aqueous raised to the first power. But solubility problems are nice. In fact, they're called solubility products because you don't have to worry about a denominator. There's no division. It's just products, multiplication. We've got an equilibrium expression, we've got an equation for it, and we have a constant. For a given temperature, the concentration of the silver ion squared times the concentration of the chromate ion will always be 8 times 10 to the negative 12. Pretty small numbers. The silver ion and the chromate ion are both going to be small. Molar solubility, which is different than the solubility product. The molar solubility can change a bit depending on what other ions are present. Now, the molar solubility is how much of this stuff dissolves in a liter of water. There's a 1 here. So if we call this molar solubility S, and that's usually the abbreviation that they give this, italicized S, that's the molar solubility S. If you know how many moles of this will dissolve in water, then of course this will be 2S, and of course this will be 1S. We've got our coefficients, how moles end up react. If we put this into the equation, this is what we get. This is probably all you need to solve it now because we're going to be solving for S and the rest is algebra. So in this problem, you had to know that molar solubility would be this S, and you'd plug it into, well, you don't have to know about this balanced reaction. And then now we put in the numbers. Let's get our numbers in. 8 times 10 to the negative 12, our solubility product, is be equal to how many moles dissolve cubed in a liter times 4. The rest is solvable for you. You can see why this is something that only students who get a 5 would end up getting. It's a tough one. And notice here, you didn't have to do the calculation except for a division. Now let me go to what we had on the outline. The relationship between molar solubility, S, and the KSP. This is something, there's always a question, maybe 2, maybe even 3 questions in an AP exam on it. So if you've got a simple substance, it's S squared. If you've got something like this, you're going to get 4S cubed. Now you could memorize these, if you're really good at memorizing stuff. If you know about the ions dissociating, you can figure this out mathematically. There's a solution to that. Oh, by the way, if you figure this out, you're at the top level of AP Chem.